I try to imagine a fellow smarter than myself, and then I try to think, what would he do?
Charge up your axons, ready your receptors, and shift your lobes into upper beta phase. You are listening to Smart Drug Smarts, the podcast dedicated to helping you optimize your brain with the latest breakthroughs in neuroscience, nootropics, and psychopharmacology.
Hello and welcome to Smart Drug Smarts. My name is Jesse Lawler. I am your host, and this is the 143rd episode of this podcast dedicated to the ongoing betterment of your brain by any and all means at your disposal, even including those that might make you pee in strange colors. Some of you who are familiar with the topic of today's episode will already know what I'm going to be talking about. We're going to be talking in this episode about Methylene Blue, a really interesting compound. It's an oldie but goodie, a synthetic compound invented over 100 years ago, been used for a bunch of different things. It's kind of like the Force. It can be used for good or evil, but we're going to be learning all about it when we talk in the main interview with Dr. Francisco Gonzalez-Lima from the University of Texas, who is one of the leading experts on methylene blue and will be guiding us all around this topic. If you hang around until the very end of the episode, I'm going to tell you about a recent study on social media and how social media stacks up so far as our brain is concerned, occupying the slots that are apparently there for friends, family, and social relationships. Are there advantages to social media over real life stuff, or is it the other way around? Seems like everybody's got an opinion on that these days, and now we'll get you a little bit more data to back up your opinion. But right now, let's kick things off first with This Week in Neuroscience.
Smart Drug Smarts, This Week in Neuroscience.
So I'm a big proponent of curiosity. I think curiosity generally does much more good than harm. But of course, there are famous counterexamples. Curiosity killed the cat is a phrase everybody knows. Pandora's box from Greek mythology is basically the same concept, extending even beyond felines. But some marketing researchers were wondering recently just how far human curiosity goes, how far people are likely to go to get the answer to something when there isn't any visible upside. The results, probably not surprising, are that most people find not knowing the answer to something more annoying than knowing the answer and finding out something they wish wasn't true. They did a handful of experiments, but probably the most interesting one was putting college students in front of computer screens that had 48 buttons. The buttons were labeled nails, water, or just a question mark. And the students had the option of either pressing the buttons, as many buttons as they wanted, as few as they wanted, or just sitting out the clock and sort of waiting out the experiment. If they pressed the button that said nails, it played the sound of nails on a blackboard, so a universally despised sound. Pressing a button that said water played the sound of water being poured into a jar, so maybe a modestly positive but generally fairly neutral sound. Even if you happen to like the sound of water being poured into jars, you probably don't like that sound as much as you dislike the sound of nails on a chalkboard. And then the question mark played one of the other two sounds. You didn't know which until you pressed it. So different students got different arrays of these buttons with nails, water, or the question mark. Some students had relatively few question marks among the nails and the water, while others had as many as 44 out of the 48 buttons marked with question marks. But what was of interest to the researchers is that the button pressing trended up the more question marks there were, with an average of 39 button presses for students that had 44 of the 48 questions being question marks. So a whole lot of ambiguity for that group, but not a whole lot of good outcomes. Nonetheless, most people pressed, whatever that is, upwards of 80% of the buttons in that case. None of the question mark buttons had anything other than one of the two labeled sounds. There were no positive Easter eggs. There weren't going to be angelic choirs or ecstatic orgasms or anything like that. The best they were going to get was water. But still, they saw a clear trend. The more unknowns, the more ambiguity, the more button pushing, even at the cost of that very likely negative feedback. Said the researchers, "We don't suggest that individuals should never satisfy their curiosity, and we realize that curiosity resolution can yield valuable knowledge. But we also wish to make the contrarian point. Curiosity resolution is not always beneficial." I'm not sure that I agree with the experiment design in this one, because I feel like we're a lot more curious about things when we're in a stimulation-starved environment. If you're locked in a prison cell with nothing to do, you're going to be looking at every nook and cranny, examining the walls carefully, blah, blah, blah. But I think in most normal environments, once we have no particular reason to believe that indulging our curiosity on something is going to lead to a good outcome, if there's something else to do, we're probably going to do that something else.
Smart Drug Smarts, the podcast so smart, we have smart in our title, twice.
Picked up a 5-star review this week on iTunes from listener Camden Parker, who says, "I am a recent neuroscience major who's about to embark into the wonderful world of research. I have a girlfriend who lives a long distance away from me, and your podcasts are a great way to break up the monotony of driving. I've learned many things, and I always have something interesting to talk about to my girlfriend when I arrive." He also says his name's Mac, so I guess maybe his name isn't Camden Parker. Either way, happy to make your drive exciting. Hopefully your girlfriend who hasn't seen you in a long time wants to hear about neuroscience instead of just wanting you to shut up so she can have her way with you. But who knows, maybe she's really into neuroscience. Speaking of lovey-dovey stuff and the brain, actually, we're going to have another Know Your Neurotransmitters episode sometime in the next couple of weeks. It's actually technically a neuropeptide, not a neurotransmitter, but I spoke with an expert on oxytocin, the fairly well-known love hormone within the brain, and that's going to be a really good one, really interesting one coming up. Stay tuned for that, just a preview of things to come. If you want more in the way of previews and more in the way of me going totally off topic, of course, you're strongly encouraged, invited, threatened into signing up for our newsletter at smartdrugsmarts.com/newsletter. We call that the Brain Breakfast. The latest one actually had nothing to do with any episode at all, but I went to a flotation tank last week. Not my first time and definitely not my last time in a float tank, and just had some thoughts I wanted to get down. When those sorts of things happen, the Brain Breakfast is generally where they go. And we also put in links from around the web on stuff that we're looking at, reading. For all that behind the scenes sort of material, links in your in basket once a week. Do sign up for the Brain Breakfast. I also should give a hat tip to Abelard Lindsay, who we've interviewed a couple of times on this show. Citizen biohacker par excellence, and the man behind the formulas of Nexus and Mitogen. He was actually the guy that actually first introduced me to Methylene Blue. As we will hear in the coming interview, although this is a synthetic compound, something that was invented by humans, it has profoundly useful effects on mitochondria. Mitochondria are kind of the focal point of the ingredients that we put together into the compound mitogen, which, sidebar, is available over at axonlabs.io. And we considered maybe Methylene Blue is something that should go in there. But based on the considerations that you're going to hear, particularly around the dosing and the fact that your pee turns blue, we figured that would be a lot to explain and not the kind of thing that we wanted to allow people to get wrong. So Methylene Blue is not a part of mitogen, but it was a contender, definitely an also ran. So anyway, hat tip to Abelard, we're finally getting around to this episode. But mitogen and Nexus both are available on the web at axonlabs.io. If you're about to start school, you're looking to bring your brain back online, the Axon Labs stacks are a great way to do that, so definitely check those out if you get a chance. That's all the news and updates for this week, so let's jump ahead now to the main interview.
Smart Drug Smarts.
So I'm about to be speaking with Dr. Francisco Gonzalez-Lima, who's with the Texas Consortium in Behavioral Neuroscience at the University of Texas. And he has been studying the star chemical of this episode, methylene blue, for a number of years now, and is going to be leading us on over a 100-year journey through the history of this chemical up until the research that he and his team have done personally. This is a truly interesting chemical. We're going to be talking about everything from malaria treatments to the electron transport chain used by your mitochondria for intercellular respiration to hormetic effects and proper dosing to make sure that something helps you and doesn't hurt you. So lots of material. This one does get a little bit biochemistry heavy, although certainly you don't need to be jotting notes on all those parts to get the main gist of what he's talking about. Dr. Gonzalez-Lima does have a bit of an accent that might be difficult for some people to pick out all of what he's saying. There's a compound he refers to a couple of times called cytochrome oxidase, for those of you who are taking notes on the biochemistry. One other thing that's in here that's a little bit hard to understand the first time it's said is magic bullet. But that phrase, magic bullet, was originally coined, apparently, around methylene blue. Now that I've given you a warning, when you hear it, you'll know exactly what I'm talking about. You'll be like, that was easy to understand, but a test listener for this interview didn't catch this the first time, so now you've been warned. We do talk about turning your pee blue. I don't know if that requires a parental advisory for explicit lyrics sort of warning, but just so you know, that's coming up. But let's jump into the interview now with Dr. Francisco Gonzalez-Lima.
We started studying methylene blue about 15 years ago. We were looking to improve mitochondrial respiration. And in the process of doing this, I had to really go far into the literature, literally 100 years. This compound this year in 2016, it's already 140 years old. It was a dye for textile in 1876, like the beginning of the Industrial Revolution. But it took about 10 years for scientists to inject methylene blue into an animal. This was also done in 1886 by Paul Ehrlich. He did that. He found that methylene blue, even though it was injected to the whole animal, it would go and concentrate particularly in the brain. And this actually led Ehrlich to came up with the term that is used nowadays all the time of magic bullet.
Really? That's where the term came from?
Yeah, Crane came as a magic bullet because he will give it to the whole organism, but then it will have a selective uptake by respiring nervous tissue. And that's the key. The animal have to be alive for methylene blue to go in and start depositing in the nervous tissue. So 1886, this was a very incredible reaction. It was called the Ehrlich reaction and led to the opening of this idea that there could be a selectivity or specificity of chemicals for certain tissues in the body. This led to the beginning of what nowadays is called chemotherapy. body, using chemicals to target tissues in the body. The history is very rich. So one of the things that was done was also to use this to label neurons, the individual process of neurons. For example, dendrites in neurons were discovered using the Golgi technique, but there was a lot of hesitation. This was done by Santiago Ramón y Cajal, and then he started using methylene blue in the 1800s and was able to show that the animals, if they were alive, injected with methylene blue, then you process the tissue and you can find that this methylene blue will concentrate in dendrites along the nervous tissue.
Yeah, very interesting.
Yeah, so there was a history of these two people are Nobel Prize winners in medicine. So from the early days, methylene blue was making an important impact in many disciplines, including neuroscience. What we found, there were earlier reports, but there was one in 1930 by somebody called Guzman Barron. And in 1930, they demonstrated in living cells that methylene blue could increase oxygen consumption. And this was, for me, the most important hint that this compound could have an action on this respiratory enzyme. And then 30 years went by. The next important work happened in the 1966. They found that methylene blue can donate electrons and can increase oxygen consumption in biochemical studies. So we basically make the jump from these biochemical in vitro studies to try to test this into living rats. And we published our first study on that in 2002. First of all, we verified that indeed methylene blue could improve oxygen consumption. For example, taking the brains out from the animals and doing biochemical analysis found that it could increase cytochrome oxidase activity, this respiratory enzyme. And I think at the time, one of the important findings that we were interested in was the fact that in Alzheimer's disease, there is inhibition of cytochrome oxidase. This was something that was discovered in the 1990s. And for a long time, I worked with my trainees to develop quantitative histochemical method for measuring the amount of cytochrome oxidase in nervous tissue. And then we applied that to the methylene blue studies and found that methylene blue indeed was increasing cytochrome oxidase activity demonstrated in the tissues. Then the big question that we have, can we, by doing this, by improving cellular respiration, which in turn improves energy, can we improve memory? And those were our first studies in 2002, 2004. And from there, we done 20 different studies showing that methylene blue can enhance memory and is also neuroprotective, ranging from, different species, starting out with rats and mice all the way to humans.
The memory enhancement effects that you've seen, is that for long-term memory or working memory or some combination of both?
All of the above. There hasn't been any form of memory that we have tested that hasn't been improved by methylene blue. And the reason for this is not acting on any particular specific neurotransmitter system. It is acting on providing energy to respiring neurons, and whatever they're doing is facilitated. So in many of these experiments, we give the methylene blue after a learning experience, and then we test one day later or several days later, and we see that the animals have better memory retention.
How long does methylene blue actually last within the body? Is this something with a short half-life that's cleaned up quickly, or does it hang around for a while?
It has a half-life of approximately 12 hours. The reason for that is, you remember I mentioned Paul Ehrlich.
Yeah.
So Paul Ehrlich, one of the big challenges in the 1890s was malaria, and he decided to try methylene blue in malaria. And in fact, methylene blue became the first drug, synthetic drug, in the history of medicine to be used against the disease in humans. And it actually became then the first synthetic chemical used as a lead compound for creating other pharmaceuticals. So because of this, all of this pharmacokinetics is being studied for over 100 years. And it has been given to humans for malaria for a long time, all the way to World War II. It was being used for malaria. For example, the U.S. Navy, if you read the biography of Eisenhower, you read about the Navy man saying they were Navy man so blue that they even pee blue. And this has to do with the excretion of methylene blue. So it lasts about 12 hours. And during this time, several hours after you take it, depending on your hydration, you start excreting it. And you excrete essentially the parent compound that is not metabolized.
That's interesting.
So different from other chemicals. Yeah, methylene blue has unique chemical properties that I have unfortunately not found in any other chemical. But it's eliminated eliminated through the kidneys, so it accumulates in the bladder. By several days, you stop seeing it. It stains the urine bluish, depending on what the color of the urine is. If it's clear, it's blue. If it's more yellow, and it looks like green.
I could see where that would scare somebody if they weren't expecting it.
And actually, for this reason, it's being used for jokes and so on in the medical community.
Right.
And also for compliance of taking medications, very small amounts of methylene blue, so that see that people are taking the medications.
Yeah, I've heard it's also been used as an active placebo or like a decoy placebo because people can see their pee turning blue, and so they assume something must be going on.
That's correct, because when they see that, it's an unusual kind of placebo in that sense, because most placebos don't have any kind of action. But in this case, I think it's more than a placebo. It's misleading people to thinking that there's an action. But yes, I think that's an important point talking about the dose, because I think one of the most problematic aspects on the use of methylene blue has to do with the dose. All of these benefits that I'm mentioning about methylene blue have to do with very low doses. Doses that are less than 5 milligrams per kilogram of body weight. In living animals and humans, we have used between half a milligram of methylene blue to about 4 milligrams per kilogram of body weight. And this is important to mention for safety reasons, because methylene blue has hormetic dose response. So it does the opposite effect at low doses and at high doses. And at some intermediate doses, it actually has no effects. And this is strange for people who are used to think that the more, the better. That's not at all the case with methylene blue. So all of its benefits depend on being at very low concentration when it gets into the nervous tissue.
So what are the specific results in the case of an overdose? Somebody or some animal taking too large of a concentration for their body weight, what happens?
Methylene blue at low doses is a lifesaver. For example, if you have in emergency room, the only treatment available for things like cyanide poisoning, the classic poison, or carbon monoxide, or any metabolic poisoning that affects oxygen utilization is methylene blue. Getting people on intravenous low-dose methylene blue, this is a lifesaver. However, if you give a high dose, you produce the opposite. You interfere with blood cells, the red blood cells, and you produce death. So it goes from lifesavers to a killer, depending on the dose. So it is very important then to be mindful about the dosing. And I think in the U.S. presently, the only FDA-approved use of methylene blue is for something called methemoglobinemia, which is when the hemoglobin in the red blood cells cannot carry oxygen because of one of these metabolic poisons, like cyanide or rotenone or any number of toxins. However, high dose of methylene blue causes methemoglobinemia. However, this is the only FDA-approved use. This use was approved this year for the first time, 2016. However, before that, the FDA has given methylene blue what is called a grandfather status, because the drug that has been used for over 100 years before the FDA was created, it was grandfathered. This year, for the first time, they gave it officially because, like I mentioned, it's the only antidote available for metabolic poisons.
Thinking about how important dosage is, but you mentioned how methylene blue tends to accumulate in areas that are metabolically active. So something like our brain, where we have a lot of activity, a lot of energy that the body gets spent and consumed, that's where methylene blue will tend to accumulate. So I guess what I'm wondering is, let's say you have an obese person who has the same amount of metabolically active tissues,
yes,
but has a whole lot of extra tissues as well. Is that going to change the dosing to hit the correct threshold of concentration?
Yes, because one of the things in pharmacology, when we make dosing based on body weight, this is an assumption that all body weight is the same kind of tissue. But for example, you can have a rat that is 200 grams and you can have a rat that is 400 grams. If you were to give the dosing to these rats by body weight, you will give twice as much dosing to the 400 gram rat. However, a 400 gram rat doesn't have a brain that is twice as big as the 200 gram rat. Fortunately, because of the magic bullet effect, methylene blue will go and become trapped in actively respiring cells, which will be nervous tissue cells. So all of this extra amount of fat will not affect that property. However, what would affect the property is if you actually inject twice as much amount of methylene blue to that 400 gram rat. In the range that we see beneficial in animals, this still will not be a problem, because we're saying between half a milligram to about 4 milligrams per kilogram. So you have a range there of 8 times that is still within safe low concentration. So humans for intravenous is usually used 2 to 3 milligrams per kilogram IV. So if you use the lower range, even though somebody is getting more because of the body weight, you can give twice as much methylene blue, and that will not be a problem. All of that adipose tissue is not going to result in any significant change in the fact that methylene blue will concentrate in the respiring nervous system.
So it's really interesting that it's not broken down within the body. Is that to say that it's behaving like an enzyme? It's facilitating other reactions?
No. Methylene blue has a unique biochemical property. I already told you about the hormetic dose response that happens with other chemicals. But methylene blue, first, it targets respiring cells. So it can target a particular tissue, like tissues that use more oxygen. Methylene blue accumulates more. And the reason it does that, it has an auto-oxidizing property. Methylene blue turns from reduced to oxidized, so that they call it a redox agent. When it's oxidized, it's blue. And when it's reduced, it's clear, becomes transparent. You may have heard years ago this was done in chemistry labs, teaching chemistry to children, the so-called blue bottle, where you will put methylene blue and the water will steep blue, and then you will put a reducing agent, and then it will start becoming clear, and then you could agitate the bottle so air will go in, and then it will start becoming blue back again. So this is the key to the methylene blue action. From the oxidized form, it affects hydrogen, it affects protons, becomes reduced, and then it donates those hydrogens. For example, it can donate those hydrogens to oxygen and form water. So at low concentration, it reaches an equilibrium between the oxidized and the reduced form. And this low concentration is where it accumulates inside mitochondria, next to the electron transport chain. So what it does in the electron transport chain, it then donates electrons. So this is why the drugs that I mentioned, the poisons like cyanide, they block points in the electron transport chain. That's why people die quickly, because they cannot use oxygen. So methylene blue essentially provides a bypass. In other words, electrons can flow through methylene blue, and then it donates them back to one of the electron carriers in the electron transport. For example, cytochrome oxidase, the last enzyme, the respiratory enzyme, is to reduce oxygen into water. That process is called phosphorylation or oxidative phosphorylation to produce energy. So methylene blue acts as an electron donor, which are these chemicals you produce when you eat foods that can produce energy. When you eat something that you say it has this many calories, the bottom line is something that is going to be able to produce some ATP that can be broken, the phosphate and heat being released. Well, actually, methylene blue is feeding you without you having to eat.
Interesting.
And it keeps doing this as long as it's there. Because of this equilibrium at low concentration, it keeps recycling. It captures electrons, for example, free hydrogens available in the mitochondrial matrix, and shifts them into the electron transport to facilitate your production of energy.
Once the methylene blue is inside the cell, it's up against the mitochondria performing this function. How is it that it gets cleaned up at the intracellular level and winds up back out in the bloodstream where it can be cleaned up and peed out?
Methylene blue, when it changes from reduced to oxidized, every time that it's in the reduced form, it can pass through the endothelial cells, the walls of the capillary. So as time goes by, the fraction of methylene blue starts disappearing. The original one that you administer is in the oxidized form. At the surface of the endothelial cells, it becomes reduced and passes inside the capillaries. Then in that form, enters the cell and it finds its way to the mitochondria. And when it's there, the same process happens in reverse. Every time you have a larger fraction of reduced methylene blue, some of that gets into the circulation and then is removed through the kidneys. And then it starts building up in the bladder. And you remember when it's in high concentration, it does the opposite. So when it builds up in the bladder, it acts to kill cells. And this is particularly the case when you have something like a bladder infection. So one of the uses of methylene blue until, I would say, about 10 years ago, in the U.S., there was an oral pill that was called Urolene Blue. And Methylene Blue was used for people that had urinary tract infections. But with the use of antibiotics, now basically no physician prescribes anything other than antibiotics for this urinary tract infection. However, Methylene Blue was highly effective because in the process of being excreted, when it built up in the bladder, it killed bacteria and viruses.
I saw in some of your studies that you were using methylene blue in the studies in conjunction with light. And I wonder if you could talk about that, or if there's additive effects, or how light and methylene blue might interact.
Let me clarify. I actually have not used it in combination.
Okay.
I have used these two different approaches. One, the low-dose methylene blue to facilitate mitochondrial respiration. And in the process of doing that research, finding for another way to do the same with another intervention, it was about 8 years ago, we found that we could use near-infrared light to directly pass photons to cytochrome oxidase. Just like methylene blue was passing on electrons in the electron transport, near-infrared light penetrates through the tissues, and cytochrome oxidase at particular wavelengths becomes a photon acceptor. So that's what we have used. We have used near-infrared light to also stimulate cytochrome oxidase and produce similar kinds of effects. In fact, we've done the studies in parallel. Everything we've done with methylene blue, we have been doing with near-infrared light, near-infrared lasers, and shown that we get the same kinds of effects. In fact, the light is more specific to cytochrome oxidase activity, whereas methylene blue can have other actions, even though most of it is focused on the electron transport enzymes. But let me explain. So if methylene blue itself affects light, you remember I told you that it affects hydrogens and becomes reduced, and then when it auto-oxidizes, it can bind those hydrogens to oxygen, other compounds. So if you send light, for example, if you have in your skin a skin cancer, a melanoma, and you inject in that skin cancer, you inject methylene blue, and then you shine light on top of it, methylene blue will grab those photons from the light and then will act as a pro-oxidant and kill those tumor cells. So methylene blue is used for what is called photodynamic therapy to kill cells in the presence of bright, high-intensity light, and not very well known by people. Blood that is used for transfusion in hospitals. When we had the big epidemic with the HIV infection, one of the ways that this blood is clean, disinfected from viruses, is by putting methylene blue in it and then subjected it to light, this bright light, as photodynamic therapy to kill HIV. So if anybody has gotten a blood transfusion, he has gotten methylene blue in it. Like Ehrlich says, is a magic bullet. Light, we found, can get into the cytochrome oxidase and produce similar effects, but methylene blue has these other actions that are unique. And it's something that, there is a lot of interest in antioxidants. Yeah. And there is no better antioxidant than methylene blue, because methylene blue, while it is inside mitochondria, the main reactive species is reactive oxygen that is partially reduced in the process of cellular respiration that happens inside mitochondria. So the first free radical that is formed inside a cell is superoxide, and methylene blue will bind to superoxide to fully reduce it to water. So when you are using more energy that you're breathing and you're consuming more oxygen, there's always a small fraction of that becomes superoxide that produces this so-called oxidative stress. If methylene blue is on board at low concentration, methylene blue binds to that superoxide and reduces it to water. So it stops the oxidative damage cascade at its very beginning. Whereas other antioxidants, the best they can do is work at the level of the membrane of the cell to prevent, for example, lipid peroxidation. But this is after superoxide has been formed, superoxide has been transformed into hydrogen peroxide, and so on, which are all producing damage to proteins, damage to DNA. And when they get to the lipids, most of the antioxidants available through nutrition can do something about stopping that peroxidation cascade. But the only one that can stop at the very beginning, and in fact leads to no damage, is methylene blue. And this is the reason for its strong neuroprotective action. So methylene blue has a unique dual property. On the one hand, it can increase cellular respiration, energy production, and normally that leads to more oxidative stress. But at the same time, methylene blue eliminates the oxidative stress. It acts as an antioxidant at that initial level in the mitochondria. So it has a double whammy of being a metabolic enhancer and an antioxidant.
Is it only the fact that there's sort of this threshold concentration at which it becomes dangerous? At the lower dosages, it sounds like there's nothing but upsides. Is it just the dosage concerns that keeps this from being something that we put in the water supply, put in every kid's lunchbox? Are there any downsides if we get the dosage right?
Nothing that I have found. Nowadays, there is a revival of giving this to literally thousands and thousands of people, especially children in Africa, because the malaria, one of the reasons Methylene Blue benefits against malaria, there are several reasons. The ones that I just described for the low concentrations, but one of the reasons is Methylene Blue affects an enzyme that is unique to the malaria parasite. But after the discovery of the quinines that they were discovered in South America, that's where the Indians use them from the bark of the tree. Since that time, the quinines has been the treatment for malaria. But in places like Africa, the parasites have now become tolerant to the quinines. So they have reintroduced, especially German scientists have reintroduced treating people with Methylene Blue there. And they usually have campaigns in which they treat thousands of children for several days in a row with oral Methylene Blue. The doses that they use orally there are actually more than 5 milligrams per kilogram. They usually have between 7 and 8 milligrams per kilogram. But the difference there is that the children also have lots of parasites, intestinal parasites. And Methylene Blue gets into those parasites and then kills the parasites, and it gets excreted before it ever gets into the circulation. At least half of it is lost through the intestine. So with these larger doses, it promotes diarrhea. But the diarrhea is beneficial because it's very time limited and it's coupled with the elimination of these intestinal parasites. So it can be managed very well.
So why wouldn't it have similar beneficial effects on the parasite? Like say I've got a tapeworm. Why wouldn't Methylene Blue be a positive, a benefit for the tapeworm, the same way as it conceivably would for me?
Yes, two reasons. One, in the malaria parasite, there is an enzyme that is specifically sensitive to Methylene Blue. So it weakens the parasite, and then our body immune system kills the parasite. And then secondly, that's specific for malaria. But for other parasites like general intestinal parasites, when you take it orally, when it gets to intestine, it's in high concentration. And there, it promotes an antiseptic effect, just like what happens when it accumulates in the bladder. So it helps with the intestinal parasites, and any overabundant intestinal flora is reduced. So normally, if you don't have the parasite, then it will slowly be absorbed. For example, the more acidic is the environment, like in the case of in the stomach, the quicker the Methylene Blue gets absorbed into the circulation. So when they give it for these purposes, they try to avoid being mixed with something that would lead to reduction of Methylene Blue, so it gets into the intestines and then does this action. But the malaria parasites are throughout the body, so it has to be absorbed at some point to be effective.
And what is the legal status here in the U.S.? As I understand it, it's something that a person could buy over the counter if they had a mind to.
Not if it is a pharmaceutical grade. And this is a very important consideration for safety, because Methylene Blue has all these uses. It's available in like 3 different categories of purity. Purity that is appropriate for human consumption, so-called pharmaceutical grade, or USP, the United States Pharmacopoeia grade. Yes, you can get this on the web nowadays from reputable chemical companies, the USP grade. However, if you're going to consume this, you need to have it as a prescription, for example, with a compound pharmacy that can come up with a pill that a doctor can prescribe. For example, in our experiments with humans, we get a compound pharmacy to prepare the pills. Less than 10 years ago, Methylene Blue was available for urinary tract infections, but not anymore. Then there are 2 other purity grades that should not be used by people. One is the chemical grade, which can be as low as 85% purity or less, which is sold by these chemical companies like Sigma. It is unfortunate that that one is used because it also has been used for experiments with animals or living cells, and that one contains impurities that are toxic. And then some of the misleading results from Methylene Blue studies are usually explainable because they were using a low purity preparation like the chemical grade. And then there is still an industrial grade that is even less pure, that is used as a dye in the textile industry, like blue jeans machines used to be dye with this industrial purity. So the chemical grade is also available in pet stores that they put it in fish tanks to eliminate when fish have parasites on the surface. They put this into the tank to act as an antiseptic. So I obviously do not support the use of any of these chemical or industrial grade for consumption by anybody.
Right.
The pharmaceutical grade, and the best is to have these prescribed to rule out any potential side effects or interactions. That's the way to do it. In other places like Canada, there are more physicians doing this than in the U.S.
Given the general usefulness, this is something that could conceivably be useful to any living organism. If somebody wanted to get a prescription for this and they're talking with their doctor, is this something that's prescribed only to solve certain problems? Or can you just say, hey, I want more energy and a better memory, and I've got no real interest in the color of my pee. Can you prescribe this?
Well, right now, they can do it off-label. For example, a physician in Canada who completed a study recently with Methylene Blue in bipolar disorder, he gives this to his patients. Even after the study was finished, the people saw the benefits and they asked, so he continues to get this done by a compound pharmacy. The main issue with Methylene Blue nowadays in terms of commercial availability is that no pharmaceutical company wants to invest in having Methylene Blue as pharmaceutical compound, especially in oral form, like a capsule, because they are afraid that any other company can do the same, and therefore they will not make profits. And we have a situation that is incredible in which nobody makes it because
it's like a Mexican standoff among potential manufacturers.
Somebody else may make it and also make money with it, and then nobody makes money on it, and it's not available to benefit people. So the only one that is being produced now that is available as a regular pharmaceutical drug is the injectable solution that is for intravenous injection. That is the one that is used in the emergency rooms, which should be in every emergency room is available. And there are 2 different companies now that are still producing that, which is usually like a 1% solution. With the advent of the antibiotics, the main use for that oral form was eliminated, even though I must say nowadays we have a real important problem in older people, especially older women, postmenopausal women with chronic urinary tract infections who are repeatedly going through rounds of antibiotics in their old age. And Methylene Blue has been used, has a successful track record of being used for that purpose alone, just by concentrating on the bladder. That alone justifies having Methylene Blue available commercially, but it's going to take some time. And I shouldn't finish this without mentioning there is an English company that is trying to develop Methylene Blue, or right now actually a derivative of Methylene Blue they can patent for Alzheimer's disease. And there are currently trials going on throughout the whole world. The problem with this is that they're basing their studies on the knowledge that was found in vitro that are high concentrations. Methylene Blue, because of this pro-oxidant action, prevents the aggregation of these tau filaments formed the neurofibrillary tangles in Alzheimer's brain. However, it would be misguided and even dangerous to try to use these levels of Methylene Blue in humans to try to accomplish that objective. This company has found beneficial effects in memory when they use the low doses, and they have been puzzled that when they increase the dosing, they don't get more benefits because in their model, the more Methylene Blue, the less tau aggregation, so there should be more beneficial. But that's not the case, and so far, that company has completely ignored the fact that even in healthy humans, Methylene Blue facilitates memory. It has nothing to do with tau aggregation at this low concentration.
Right.
So if this company comes up with a product at low concentration to deal with cognitive decline, that would be a very important benefit. However, there's also the risk that come up with dosing that may lead to adverse effects because their idea of trying to get rid of this tau aggregation by using larger dosing. So that will give a bad name to Methylene Blue.
Smart Drug Smarts.
So thank you so very much to Dr. Gonzalez-Lima for taking the time for that conversation. It was definitely not pulling teeth to get him to talk about Methylene Blue. I think he's clearly a man who loves his work. And what a super interesting compound. I feel like in a lot of ways, Methylene Blue is like a good explanatory compound for some of the topics that I like to think that we get across on this show, talking about things like hormetic responses, how something that can be really good at a proper low dose can turn bad quickly if the dosing is wrong. And there were some interesting asides there also that didn't make it into the final edit of that conversation. Things like how Methylene Blue can be used in some cases to try to identify intestinal cancers, digestive cancers, because cancer cells in the digestive system are respiring more quickly. And because of those magic bullet properties of methylene blue, it tends to accumulate in those areas and almost kind of stains the areas where cancerous growths might be taking place. So between the coloration and the low concentration helpfulness and high concentration deadliness, just a suite of really, really interesting attributes on that one. But as he said, there's a lot of different grades, well, a lot being 3, of methylene blue quality out there, and it is only the pharmaceutical grade that anybody would want to consider for human consumption. And this is one where, for anybody who's curious, a doctor's prescription would be strongly, strongly advised. But that's it for this topic. We've had blueberries a couple of weeks ago. We had methylene blue this week. I think that is the end of the Smart Drug Smarts blue period, because I can't think of anything coming up in the near future that's going to be repeating the color blue. If you can think of any other blue topic, something that I can tie in to make this a trilogy, let me know. But I think that might be it for now. So let's move ahead to the ruthless listener retention gimmick.
Smart Drug Smarts, ruthless listener retention gimmick.
Okay, so I found a study published earlier this year by Oxford University, and this isn't exactly neuroscience-y, it's a little bit off topic, but all of us use social media to one extent or another. I thought this was super interesting, and I kind of figured, we'll wedge it in here, maybe you guys will like it too. So you might have seen those charts where they've looked at the average brain size of different monkeys leading all the way up to humans, and plotted the size of the social group of monkeys based on a function of their brain size, and it's fairly linear. Bigger brains, more animals in your social network. And if you were to pull humans off the list and just look at monkeys and what our brain size is and what you would predict humans to have as a social group size, it winds up being about 150 people, between 100 and 200, depending on which primatologist or sociologist you ask. This is called the social brain hypothesis, but doubters of this theory have pointed out that there's a lot of other things other than how many people we're capable of being friendly with or how many people that we'd like to be friendly with that influence how many people we actually wind up being friendly with. If you live a million miles from the city and you're, in a tribal group of 15 people, you're going to have a maximum number of friends of 15 people, regardless of what your brain could support. Of course, nowadays, that's not the case for many of us. Most of us have lots of folks around us. Something like 60% of the world's population now lives in cities, which means essentially we can max out our meters on how many people that we would like to know and associate with. And then in the past 15 years, since social media has become a thing, there's been this giant migration of interaction among people to these social media networks. But what hadn't really been looked at until just recently, this study was based on data that was taken in April and May of 2015. It was not clear whether free and easy availability of extra people that we could potentially have relationships with without needing to physically go from here to there and bump elbows in the real world, whether that's changing how many people that we're having in our social groups. Psychologists talk about rings of relationship, inner layers that are like your super close friends. These have typically been called a support clique or a sympathy group. These are your BFFs. Then you've got a few layers out, which are close friends, people that you know lots of stuff about. They know lots of stuff about you. Maybe you've met their family and friends. You kind of have second level relationships with the people that are in their lives, but they're not necessarily your tightest intimates. And then, of course, the much larger layers that everybody else, like, oh yeah, I know that guy. I met him a couple times. I can talk with him without getting into a fist fight, but, we don't hang out. So they've done studies on how people behave socially online, lots of studies. But the problem has been, it's always been sort of a self-selected group. Like they've taken a bunch of people off Twitter, and those happen to be a bunch of people on Twitter. But this study, this was conducted in the UK, and they actually did a large randomized sample. There were 2 big groups, and each was a nationally structured random sample of adults between the ages of 18 and 65, and they were distributed proportionally according to age, sex, and regional population within the United Kingdom. The first group was 2,000 adults, average age 39, 45% of them were male, who were self-described as making regular use of social media, but it didn't go beyond that. Didn't specify what was their favorite social network, but just that they were social media users. The second group was 1,375 business professionals, about the same age. These people were not necessarily self-described social media users, but they were self-identified as people who worked full-time 9-to-5 jobs and who personally had attended business meetings on behalf of their employer. So they were at least professional enough to be the face of their employer or the face of their business in certain situations. So not a fry cook at McDonald's. And so they asked these groups a battery of questions, asking them for categorical answers to how many friends they had on Facebook. And then after they got that out of the way, how many of their Facebook friends actually did they think qualified as being like real friends, the kind of friends that would measure up in an offline scenario of actually qualifying for friendship, whatever that meant to the person. The results of this study wound up being a big win for the social brain hypothesis, because although everybody agrees that social media makes it conceivably easier for us to have much, much larger social groups, that wasn't really what they saw in the results from the study. Most people in both groups had network sizes that were in that 100 to 200 range. In both sample groups, only a small percentage had more than 300 friends. It was 14.2% of the first group, 13.4% of the other, so well in line with what we'd expect from this monkey brain size hypothesis. The the size of that inner circle that they call the support clique was humped between 1 and 4 people for most folks. In the somewhat bigger but still fairly intimate group called the sympathy group, most people had 5 to 10 of those. Women had significantly more friends than men, 165 versus 145 on average, and the number of friends dropped fairly precipitously as people got older. What didn't change was the number of close relationships as people got older. The size of the support clique and the sympathy group, those were pretty stable over time, but the wider array of everybody in the world that you know that qualifies as a Facebook friend, those definitely tailed off as people got older. Also, in case you were wondering, in that first sample, a sample size of 2,000 users who consider themselves social media people, only 27.6% of their Facebook friends did they consider to be genuine friends. So if somebody's Facebook friended you, there's only a 1 in 4 chance that they're actually considering you to be a real friend. The researchers also pointed out that although this study didn't start until people were 18, they said that young children and to some extent teenagers, one of the reasons that they might have larger social groups online is because they're relatively poor at judging relationship quality. Very young children commonly mistake their own desire to form a friendship with an assumption that the friendship is automatically reciprocated from the other party. And although we certainly get better at this as we age, they seem to imply that even people in that 18 to younger 20s period might not have their fake friend radar quite as well tuned as people that are a little bit older. So the final result that they put on these findings are that people do not seem to be using social media to increase the size of their social circles, and the researchers suspect that the primary usefulness of social media might be to slow or prevent the decay of relationships if there's an absence of opportunities for face-to-face contact between people. Personally, I think they're being a bit pessimistic. I've got lots of social relationships that have been formed entirely online with people that I still haven't met in person, and we've been friends for, in some cases, years and years now. I'm not sure how common that is, but I think it's probably something that will be increasingly common as time goes on, and as technology allows virtual communications to be better and better stand-ins for real face-to-face communication. Being able to do a real-time video chat versus writing a pen pal or whatever you would do in the 1980s, that's a giant difference to the quality of the relationship, and I really feel like the remaining barriers, olfactory cues or whatever that make in-person relationships somewhat deeper, those are getting whittled away really fast. Give it another decade and let's see what Skype or Google Hangouts are doing then.
We like to think of ourselves as a digital speakeasy for brain hackers, but you can call us Smart Drug Smarts.
Okay, so that is it for episode number 143. Thank you for hanging around until the very end. If you enjoyed this episode, you will find links to everything that we discussed here online at smartdrugsmarts.com/143. And we talked last week about the science of gratitude. That is the emotion, not the drug. I don't think there's a drug called gratitude, but there is a drug called ecstasy, so you can never be too sure. Next week's going to be our back to school episode, first episode of the month of September. Not exactly sure what we'll do with that one if we've got something on topic, but we'll get something for you. That'll be Friday as usual. Same time, same podcast, and with the same unflagging commitment to helping you fine-tune the performance of your own brain. Have a great week in the meantime, and stay smart.
You've been listening to the Smart Drug Smarts podcast. Visit us online at www.smartdrugsmarts.com and subscribe to our mailing list to keep your neurons buzzing with the latest in brain optimization. Smart Drug Smarts should be listened to for entertainment purposes only, although some guests on the show are medical doctors, most are not, and the host is just some random guy. Nothing you hear on this podcast or read at smartdrugsmarts.com should be considered medical advice. Consult your doctor and use some damn common sense before doing anything you think might have a lasting impact on your brain.